Good morning. I'd like to welcome you to the opening session for programmable telecom applications. For those who haven't met me yet, I'm Chris Mayer. My co-chair is Maureen Stillman. We've been involved in this conference for several years running tracks, and we're happy to welcome the people here in the audience and also our audience on the web for the live stream. So we will have actually 7 speakers in this track, and we're going to start this morning opening with Anthony Minessale. Anthony became the founder and CEO of SignalWire, a tech startup aiming to bring FreeSWITCH to the scalable cloud and make real-time communications ubiquitous and mainstream for all businesses. I'll purposely keep the introduction short. You can find full bios for the speakers on the RTC website, but I don't want to take time from what the speakers want to share with you. So without further ado, please welcome Anthony.
Hello. Get this up here where you can hear me. Everybody hear me okay? Well, not really. Pretty good? Okay, so as he said, I'm Anthony Minessale, and I'm the founder of the FreeSWITCH open source project along with Brian West, who's here in our audience. Back in 2005, we started working on this project. So as we started talking about this track here with programmable telecom, really takes us back to the origin of the entire concept of programmable telecom with FreeSWITCH, which is a software that we had been working on that many years back. So the description of what FreeSWITCH basically is: a core communication software daemon written mostly in C, which is something that was a pretty complex task to work on, like trying to write a C application that could scale and do all this different telephony stuff. But we decided that it was the best language to write it in so that it would be able to be cross-platform and run in every environment. So we chose ANSI C. So right away, we spent the first year building the core of the software, and it was able to run in most environments, popular Unix, as well as Windows environments. So really what the goal originally was is to take this complex telecom that was kind of being held prisoner by proprietary physical equipment that was way too expensive to get in the hands of an average developer, and bring them the ability to create applications in interfaces with voice over IP, which was very popular at the time. So some of the core functions of what we do with FreeSWITCH is interconnect communication protocols, taking popular things like SIP and H.323, and nowadays WebRTC, and making them all interoperable with each other, and changing all the various bit rates and sampling rates and all those things in real time, and making it possible to converge them and have a common application development environment. So it's used very heavily for routing large amounts of SIP traffic. Carriers aggregate from large upstream carriers down to residential or businesses. And it's very popular for its conferencing functionality. We have a lot of different features in it, as well as voice menus and typical things that you would want to build rather than pay endless millions of dollars for. The core is really built up of these most important components that I just listed here. The thing is, we wanted to make tools that were available to a developer to be able to integrate whatever they wanted. So at the time, there was no JSON yet when we started FreeSWITCH. We used an XML registry, which is basically a whole bunch of XML documents that are brought together that contain all sorts of information about either configuration or routing for the traffic and other stuff like that. We have an event system that produces all kinds of various metadata happening on the system while phone calls are pumping through the machine. You get event callbacks that will tell you about just about everything you need to know. We have interfaces with scripting languages, so you can embed and use your favorite scripting language to write code. And so we have also call detail records that are fairly advanced with multi-dimensional logging of every different thing that's happened in the call, not just the duration and stuff, but every time it was transferred and all these other details, every time something about it was changed, all the digits you ever dialed. And it's basically all the metadata we've ever collected during the lifetime of the call. We have a logging engine where you can write your own logging, and we have extensive module API, which allows you to write pluggable modules to extend the core. The way it's really designed is the core is meant to be protected. There's a small number of developers that make any changes to the core, and the modules are left for a developer to either use or to create their own. And that puts a layer of protection between the most important code in the software and the other layers that simplify the API so it doesn't take as much logic and programming skills in order to achieve stuff. So we built a kind of each layer up, we simplify things, and then our module APIs, you can write in a module almost completely just with our framework rather than having to write any other external code. But if you do want to make a module gateways to something else, then you can also load both of those things and extend those functionalities. So it's really just kind of an extension of the way that we're inspired by things like Apache that have been around forever that have had modular interfaces, because you never know what other stuff you want to bring together. You don't want to repeat all the same process of making a new kind of software to integrate a new functionality. So we try and take the part that's the most common and leave it there. And so the module is just changing the part that's important. So one of the most popular ones we have are the endpoint modules. Those are the ones that implement actual voice protocols such as SIP, H323. We have our own called Verto, which implements WebRTC signaling. And those modules are, we don't get a lot of people contributing those modules, but we do get a lot of use out of them. And it's one of our most popular areas of development. We have another kind of module called Dialplan, which allows you to take metadata of an inbound call and make decisions about what you want to do. It basically gives you a full canvas to do whatever you want with an inbound call. So you can program reactions, play files, route it to somewhere, bridge it to another outbound device. So it's basically your opportunity to make up your mind about what you want to do on a given call basis. So our software is very popular for multi-home, and this is an opportunity to segregate out traffic depending on where they're coming from and use things like caller ID and destination number to figure out where to route stuff. A simple configuration of the dial plan is powerful enough to build basically a soft switch that can carry like large amounts of traffic. Our file interface is the ability to plug in the abstraction of reading and writing from a file. That can be anything. One of the most popular ones that we use is libsoundfile, which is a popular open source sound file library. By using one module to integrate sound file, we instantly can support every format that library supports. But we also can write modules that register themselves as a file format but are actually streaming. So you can do things like stream MP3s or record and broadcast video to YouTube and stuff like that. We also have an ASR TTS interface, which allows you to interface to a text-to-speech engine or to a voice recognition engine. We have a few examples in Tree, the popular ones that were developed at CMU, that allows you to kind of integrate into those things, because there's an abstraction layer where we blanket use ASR or TTS module references everywhere, so no matter which one you load, the functionality will be distributed the same way, so you don't have to change everything. So if you use it in the conference, for instance, you can get a new version of a different module to replace the one you were using, and everything else stays the same. We have a SAY interface, which is a kind of the old school using the correct files based on the data. You know, if you want to say you have 3 messages, you just literally play a file for you have and then 3 end messages together. Can instantly in multiple languages string together the proper files. That goes a long way still. People kind of choose that because it's even more human sounding most of the time, if you can do it right. You have to be careful how you get your recordings so that they line up with each other, but that's been there for years and very popular. We also have a chat interface, which allows you to take the abstraction of chat and bring it into the core and then decide things that you want to do, such as getting an SMS message. There's a lot of times where you might want to make an automated SMS responder. You might be able to say, like, query what the weather is in a certain zip code or something. So you get a chance to bind inbound SMS to the app of your choice. Now we have the limit interface, which allows you to decide how many of something are allowed to happen simultaneously. And that's like a vague paradigm on purpose that you can put in the way. You can add that to your dial plan so you can, like a certain caller ID, you can only make one call at a time. Or you can limit how many times the phone can register and a bunch of stuff like that. In the back end, there's so many different kinds of back ends, so the module interface allows you to build your own. You can either use the ones we have or make your own. There's ones for hash tables that run in memory or Redis. You have a database of your choice or some other amazing backend that's capable of maintaining this kind of data. Then you can write a limit interface and use your favorite choice. Another very popular one for us are codecs, because you can use that. Codec interfaces are basically the audio encoding and decoding and video encoding and decoding that you would to use to send data or extract it from things like WebRTC or voice over IP. And we support very many of them out of the box. And as new ones are invented, we usually quickly implement a module for them. And the more modules we use, the more of them we can support. So I lost count of how many now. We have at least like 25 or something different ones. One of the most commonly used module interfaces is our application interface, which is basically the ability to interact with a call. And a call can be really whatever you want it to be. If it's a voice call in the case of SIP, it might be a video call in the case of WebRTC. But you have the ability to write your interaction, because we're talking about programmable telecom. So like some of the first things that we made possible were to take calls at high density, write applications that you could load in a very fast language and route calls to them, so that you could just basically write any code you can and use our APIs to interface with the raw traffic. You could either extract audio right out of the channel, you could redirect it, and or you could make some kind of application like a conference that will take channels coming from multiple callers and mix them together, and then send that output to everyone so that they can talk to each other at the same time. This application interface is basically used the most. Every single call has at least something happen in an application interface, and that's really the meat of where you can develop stuff. So we also have a whole bunch of built-in ones, but it's very easy to write your own also. Our FreeSWITCH API is it's very basic, text in, text out, but it has a lot of power behind it. It basically takes the most common incantation of FSAPI would be our command line interface. You can log on to the console FreeSWITCH and type commands. And if you add a new module that adds a new command, that command immediately becomes possible on the CLI. You can also create the same kind of thing that you want to be able to communicate with yourself. You write a new FSAPI, load it into a module. You can use a remote socket connection and actually interact with your new command. So you can make both sides of a data channel type of thing when you want to be able to make some kind of special signaling that has to do with the application you're developing. So we have a few books that are out to kind of explain all of this. It's a lot to go over in a small amount of time that we have here. I basically wanted to start with just a history of what our software stack does. And it's 15 years old at this point. And it's been evolving. When we first started this, SIP was really new still, actually. Most people didn't even know what it was or thought it was silly still. Now it's like overtaken basically all the different telcos. But there's a lot of history inside of these books, which are available in PAC Publishing. One of the newest things that we've been working on, as everyone has, is WebRTC. And WebRTC means something special to us because unlike some, we have this burden of maintaining backward compatibility with the VoIP stuff that has been existing for years. And like I was saying, we have this high aggregation of high density SIP traffic, voice over IP call routing and applications. And then WebRTC comes out and becomes a popular thing. And some, devices are trying to build like a WebRTC meeting, like a SFU, or maybe figuring out some way to make two browsers meet somehow, exchange media with each other. So one of the things we had to do to keep everything we've done compatible with the past was to make our own WebRTC engine so that the browser can actually call FreeSWITCH natively and communicate directly with it. That way, like in WebRTC, if you set up a video call and call our stack, we're actually decoding the audio and video if you choose. We can forward the packets if you choose. And we can bring it together and do all the same things that you used to be able to do with the older protocols, like an ordinary SIP video call or ordinary SIP audio call. You can choose in WebRTC if you want to enable audio, video, or texting, and all those things at the time of setting the call up. And we basically extended our media engine to be compatible with that, so that WebRTC applications could be made, in sort of a sandbox where there's a little bit of relief from the endless bleeding edge stuff that's going on. So we have a Verto protocol. Part of the thing with WebRTC is they have mandated that you make your own signaling protocol to stay out of that conversation. So that's what we did. We actually supported it over SIP as well. SIP is already popular, and someone decided to write a SIP stack in JavaScript. Actually, I think there's 3 now. So we made SIP was, extensible enough to make work over WebSockets, and our SIP stack didn't take very long to do that with. So these popular JavaScript SIP stacks do work, so we want to support those just out of the legacy aspects. But Verto, our protocol that we made, is really more about future-facing stuff, being able to have your call signaling channel actually deliver live data, besides call setup, information about who might be talking or other things that are happening on the system during a call. So the way we implemented this is there's 2 things to it. On one side, we have a module, and this is an example of the endpoints that I was talking about. And this endpoint module uses our core media engine, which allows you to interface to all of these, take the WebRT SCP and parse it, and uses our codec modules to figure out which codec you want to use. If you're using a chat interface, we can use that, but your web page you can type stuff and send it as a text message. And so really this WebRTC module is able to use the core of FreeSWITCH at an abstract level. So this one endpoint module is in turn using many other modules that we've written that you can, modify which version of the technology that they're using. But since it's written to the abstraction layer, it's automatically compatible. On the other side of it, we implemented a JavaScript library, which encompasses the ever-popular shim that everybody uses, Adapter.js. And on top of that, another layer of our kind of signaling library that allows you to kind of the paradigm of creating and destroying phone call dialogues. Very, very similar naming conventions to SIP, just to keep people to understand what it was, but a lot simpler in nature. Really, it's a last mile kind of protocol for setting up WebRTC signaling with FreeSWITCH itself. So what that brings us to is SignalWire, which is our next journey. All these things that we built took a really long time, and they make a lot of things possible, but they're still very difficult to manipulate. We found that some developers are confused by trying to use software as complex as ours. We spent a lot of time making it as extensible as possible, which comes with a lot of different code paths and choices and configuration options. And that really is a problem if you're trying to appeal to a wider market of developers who don't have all the time in the world to be mastering, the arts of deploying Linux servers and understanding C and building modules and stuff. So what we felt was a pretty good progress in taking the big iron Telecom and kind of making an alternative that someone could build with an ordinary PC and some willpower. We figured that now that we've reached this era where WebRTC is very popular and all these different programmable telecom ideas are coming out, and we've coined these kind of buzzword phrases like CPaaS, that it was really time for us to take this technology that might not be being fully utilized just due to the sheer learning curve it would take to work it, and come up with another layer we can put on top of what we've built so it becomes even simpler and is extensible to further amount of audience. So the whole premise of SignalWire is a elastic, self-scaling, very simple interface where we've examined what was out there so far with telecom and programmability, and there's some stuff with REST APIs, which is okay in certain cases, but really we want to look back at what we've developed along the years, which is the ability to track calls in real time where we're starting them and we're getting live events about what's happening. And the REST-based interfaces don't really lend themselves well to that, because every time there's an event, it has to call you on a REST call, and the poor guy trying to make a server has to build his own web server, make his own client, so he does a REST call. Maybe he just wants to send a text message. That works fine. Okay, it just sends it, and you can pretty much assume it'll get there unless something went horribly wrong. But you're making a call or something more complex, you want to be able to monitor the status, and you either have to keep doing polling, doing REST calls yourself every so often to see where did that call go. I made it, and now it's off into running by itself somewhere, and you could tell it to call you back once something happens, but that takes a lot of different complexity that might not be needed. So we want to take that and simplify it by using our technology stack, put together with some real-time RPC layers that we developed, and basically make it so that a developer can be in an environment like a web browser or a Node.js instance or whatever their favorite language is running on a small application, and they have two choices. They would either be able to write code, not markup language, and actually deploy it into our cloud and let us run those applications for them. So we really try to take the essence of why FreeSWITCH is so powerful and make it simple enough to use for anyone. So we also want to make it so that if you want, you can write your own applications, and you can have those applications run on your server, and we will connect. You stay connected to our platform, and every time you get calls, you'll get live events about them. You can manipulate them from your side. And we want to make that interchangeable as possible so that you'll be able to develop your apps maybe on your side and then decide that you don't want to run it yourself, and you can just save it into our cloud and we'll run it, and there won't be much of a difference between it. So, and we want to take things rather than just doing generic JSON REST calls to actually extend the ability to do things bidirectionally and unlock and create all the power of the things that we make possible, including accounts, creating provisionable infrastructure so that you can create registration accounts, put and publish them, and then sell them to your customers, and then be able to have those customers use these services. So you can basically do things like write a call center or a PBX using our backend and the UI of your choice, just using our API in real time to generate it. So that's really the premise of the culmination of everything we've been doing for 15 years is to be able to take that and simplify it, because there's audiences of millions that want to be able to do these things, but they don't have the time to learn all the complexity that we've developed as low-level developers over these years. We just started this. We've only been doing it for under a year now. Very late 2017 is when we founded SignalWire, and we've been working really hard to get it out the door. Right now we are launching it basically this week. And one of the first things we have is a compatibility layer with some of the more popular existing CPaaS platforms, which makes it a good testing environment. And then on top of that, we plan to have our extended API coming out in the next few weeks, which gives you functionality that was much beyond the plans of its traditional CPaaS. So our real goal is to really define, to take the two words we focus on the most are API and platform, which are very overused terms that we sort of want to take back and you really define them to mean what they're supposed to mean. An API is a programming interface. It's not just like 3 REST calls. And a platform is something where it runs things for you. It isn't just, a buzzword for your company. So that's really like the purpose of what we're out here to do. So it's great that we are able to kick off this conference with the first talk about programmable telecom, and I'm sure that you're going to hear a bunch of other stuff really interesting in the next couple days. And that's pretty much all I have to say. If you guys want to chat for a while, I could stay up here and answer any questions you may have.
We've got about 5 minutes for Q&A, so please, if you have questions.
It's okay if you don't.
Can you tell people how they can get involved in the open source side of the project?
You can get involved in the open source side of the project quite easily. We have a bunch of different resources, and we're about to launch some new ones. But for years now, we've had a mailing list at lists.freeswitch.org. We also have a Slack channel that we just started. We still are on IRC because we're kind of old school that way. So we've been on IRC since like mid-2000s. But we also are starting to use Slack. And our site is going to launch at SignalWire. We're going to have forums and public community site, which will also include dedicated resources for FreeSWITCH, as one of the purposes of SignalWire is to give a home to all the FreeSWITCH engineers that we've amassed over the years and give them a place to work. So we bring all those things together into that community. Yes?
I'm curious about network connectivity into your SaaS offering. Is it all just public internet? Is it, do you have relationships with service providers based in them?
Yes. Well, so we have a lot of ambition for this. We have many relationships with service providers. One of our missions is to keep the prices disruptively low because service providers are often taken advantage of by some of these CPaaS type companies who just triple, quadruple, 10x the price. We're trying to work on passing the volume through these providers to make a fair price because our main core goal is to make functionality and value add of platform hosting and not just an excuse to run someone's phone bill up, which is what we think is happening a lot of times. So for connectivity, we're very ambitious, planning to be able to support most clouds, Google, AWS, we're testing on Azure. And our platform can run on all those things at the same time. We can also segregate and run separate instances of it. Some of it is still in progress of being built, but in the end we will have entire privatized instances of the platform as well that we could put in a large install. Because we looked at something called the Uber problem. Remember the news about Uber? It got too big for their CPaaS, and then they needed somewhere to go to build their own stuff. So we've already anticipated that, like being the creators of a software stack first in a cloud, expanding to the cloud, it gives us the ability to kind of develop our stuff in a way that can run in any environment. So that's really our goal, is to make it distributed to the point where as we mature that we can have nodes of our software running everywhere on the internet.